Now that we're going to do a new video on primitives and ASCII and characters. So let's create another class, public class. I'll call it primitives char. We know what strings are. We've used them before. So string, say s equals, and we could say this is a string. Yay! And we can print out the strings, system out, print line, just put s, and as soon as we save it, then all will go well. We put in my Java examples. There we go. And there we go. We have, this is a string. Now we've seen this before, and it's really easy to use. You just write something out, some sort of text, and then you've got it. But notice that s in string is a capital S, so it comes from a different class. It's not a primitive. That is to mean it's not a fundamental part or basic part of Java. So how are strings made? Well, there's another type. We've seen, at this point, we've seen bytes, or I'll just say byte, short, int, long, float, and double. But there's another data type that we haven't seen yet, and it's called char. And so I'll just say char ch equals, and in Java you don't use double quotes for a char, you use a single quote. So I'll say t. And there we go, just a single character. So if I say system out print line and say ch, it'll just print out a single t. All right, and there is our t. So a string really is literally a string or an array of characters. And to really understand exactly where these strings come from, you need to look at an ASCII table. An ASCII table, you can see the decimal value of all of these. And so, for example, capital T will be a decimal value of 84. So it's important to realize exactly where these come from. So if I have another one, say I'm going to call this ch2 equals h, since I'm reproducing the this in here, and I do a plus sign, plus ch2, what exactly am I going to get? Well, that compiles fine. And then when I run it, I get 188, which on first glance doesn't make any sense at all. But let's go back to our ASCII table. And a capital T right here is an 84. So 84. And then if we look at a lowercase h, what are we going to have? Lowercase h is 104. Oh, that didn't write. 104. There we go. So 84 plus 144 is 188. That's right. So a character, it has a value. So it's just a primitive. So it's a variable, which means it's a memory address, and it has a value of 84. And when the data type is char, it says, oh, okay, let's go ahead and treat it as a capital T, because it looks up from this table that an 84 right here is a capital T. And if I say this other variable has a value of 104, then it looks it up the table and it says, ah, that's a lowercase h. So the ASCII table is important to understand with our characters. And ASCII is, I think it stands for American Standard Code for Information Interchange. What it comes down to is ASCII was the original character scheme for letters before they came up with something later. And the more modern one is now called Unicode. ASCII was short and fast and didn't take up much room, but it didn't have any special characters, like didn't even have the ñ in the Spanish. Like without the ñ, if you were to say Español, Without the enye, you'd only be able to say español. You wouldn't have any of the Greek letters. You wouldn't have any of the Arabic letters. You wouldn't have the Chinese characters, anything like that. Unicode has much more space, and it lets you do all of those extra characters. So what we really, in this class, will never use a char because it's not very useful to be able to have to do one letter at a time. So in this class, we'll just be using the strings itself. So just so you know, at this point, the primitives we have covered are byte, short, int, long, float, double, and char.